sklearn, cluster, spectral co-clustering. Description. Spectral co-clustering is a clustering algorithm that simultaneously clusters both rows and columns of a data matrix. It finds a co-clustering structure in the data by minimizing a cost function based on the spectral properties of the data matrix. This is particularly useful for finding clusters within a data matrix where both rows and columns have meaning, like in document term matrices, user item interaction matrices, or gene expression matrices. Inputs. Data matrix X, a 2D array-like object representing the data matrix with rows representing data points, e.g., documents, users, and columns representing features, e.g., terms, items. Number of clusters n clusters, an integer indicating the desired number of clusters for both rows and columns. Outputs. Row labels a 1D array containing the cluster assignments for each row of the input data matrix. Column labels a 1D array containing the cluster assignments for each column of a input data matrix. Steps. Data preprocessing. The data matrix X is often normalized or scaled to improve the performance of the spectral clustering algorithm. Bipartite graph construction. A bipartite graph is constructed from the data matrix, where rows and columns are represented as nodes and edges connect nodes based on the values in a data matrix. Laplacian matrix calculation. The Laplacian matrix is computed from the bipartite graph, capturing information about the connections between rows and columns. Eigenvalue decomposition. The Laplacian matrix is decomposed into its eigenvectors and eigenvalues. Clustering based on eigenvectors. The eigenvectors corresponding to the k-smallest eigenvalues are used to cluster both rows and columns. This is often done using k-means clustering. Metrics. Co-clustering quality. Co-clustering obj a measure of the quality of the co-clustering based on a cost function minimized by the algorithm. Normalized cut a measure of the quality of the co-clustering based on the ratio of the sum of edge weights connecting different clusters to the sum of all edge weights. Visualization plots. Cluster membership plot. Visualization of the cluster assignments for both rows and columns, allowing for visual inspection of the co-clustering structure. Heat map of co-clustered data. A heat map of the data matrix where rows and columns are reordered based on their cluster assignments, revealing the co-clustered patterns. Fine-tune parameters. Number of clusters n clusters. The number of clusters for both rows and columns. You might want to experiment with different values to find the optimal number. Random state. An integer used to seed the random number generator for reproducibility. Uncertainty methods. Bootstrap resampling. By performing multiple co-clustering runs with different randomly sampled subsets of the data, you can estimate the stability of the cluster assignments and assess the uncertainty. Ensemble clustering. Combining multiple co-clustering results from different algorithms or parameter settings can improve the robustness and accuracy of the clustering results. Challenges and fixes. Challenge 1. Choosing the optimal number of clusters. Determining the appropriate number of clusters can be challenging. Sample use case. You might want to co-cluster a document term matrix and are unsure of how many topic clusters to choose. Fixes. Elbow method. Plot the co-clustering quality metric against different values of n clusters and look for an elbow point indicating the optimal number of clusters. Silhouette score. Calculate the silhouette score for different values of n clusters to assess the quality of the clusters. Cross-validation. Train the co-clustering model on different subsets of the data and choose the number of clusters that performs best on unseen data. Challenge 2: sensitivity to data preprocessing. The performance of spectral co-clustering can be sensitive to the normalization or scaling of the data matrix. Sample use case: you co-cluster a gene expression matrix and observe different clustering results, depending on the scaling method used. Fixes: standardization. Scale the data to have zero mean and unit variance, which can be effective for data with different ranges. Normalization: scale the data to have a unit norm, which can be helpful when the data has varying magnitudes. Experimentation: try different preprocessing methods and select the one that leads to the most meaningful co-clustering results.